Alright, so I talked briefly about reference angles before. Now we're going to get into reference angles and how they will be able to help you a little bit better. Keep in mind reference angles are always less than 90 degrees. And they're also always, so that means they're always the distance from wherever your angle is to your horizontal. So in this case, if you're in quadrant 2, it's going to be the distance from here to your horizontal. It is not, okay, and I'm going to draw in red, it is not the distance, how many degrees it is, back to your vertical. Okay, this is not how you find a reference angle. That is a no, 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 no. Don't do it. Don't do it. You do it, I break your thumbs. So in this case, if you're in quadrant 3, the distance from your horizontal to your line is from here. And in quadrant 4, you would be from here up to your horizontal. Now there are different ways you can find your reference angles. If you're in your second quadrant, you just take pi minus your theta. Or if you're in degrees, you just take 180 minus your theta. So say you're at 135 degrees. Then you would take 180 degrees minus 135 degrees, and that gives you 45 degrees. That means you have a 45 degree angle from here down to your horizontal. And the nice thing about that is if you have a 45 degree angle, then you can use your special right triangles, and you know that this would be a radical 2 over 2 on your y value, a negative radical 2 over 2 for your x. And you'd be able to evaluate your functions easier that way. Same thing if you are in quadrant 3 though. Since your actual angle is bigger than 180, you want to find the distance back up to 180, so you would take your angle minus 180 or your angle minus your pi. So say you're at 5 pi over 4. So you go all the way around, 5 pi over 4. So you take that minus pi, you would get a pi over 4. This is your reference angle. That reference angle, okay, that's a 45 degree angle. Once again, you'd be using the numbers radical 2 over 2, comma radical 2 over 2, but since you're in the third quadrant, they would both be negative. Then finally, once you get into your third or your fourth quadrant, here you're going to take either 2 pi minus your theta or 360 minus your theta. So if you are here at 330 degrees, say this takes you around to get 330 degrees, then you just take 360 minus 330, and you end up getting 30 degrees. That would be your reference angle. And notice reference angles are denoted by a theta with a little apostrophe up here. So that is how you tell the difference between a reference angle and an actual angle. So let's look at example 4 here, where you have to actually find reference angles. And in this case, we're going to look at 300 degrees. So for 300 degrees, you are in quadrant 4. So since we are in quadrant 4, what we're going to have to do is you're going to have to take 300, and since it's in degrees, you're going to take your theta prime, is what we call that, is 360 minus 300 degrees, which gives you 60 degrees. So your reference angle, theta prime, is 60 degrees, and that will work out because you have an angle that is less than 90. It's an acute angle. It's an Mr. Klein angle. Knee slapper. Alright, here for 4b, you have a 2.3. I don't see a degree up here. Huh. Weird. Oh, so that means it's radians. Gotcha. Where's 2.3 radians? Well, if you think about your circle, this over here is pi, which is 3.4 radians. Half of 3.4 is a 1.57. So if we're at 1.57 here and a 3.14 on the left, that must mean we are in quadrant 2. So we're going to have to take pi minus our angle. So we are in quadrant 2. So here we find our reference angle by taking our pi, or in this case, since we're using decimals, we'll make that a 3.14 minus 2.3, and that gives us a 0.8 0.84. So our reference angle, our theta prime, is a 0.84, and that's radians. So we'll just abbreviate that. Even though it's not in terms of pi, it's still a radian. Now finally, for 4C, if you're at negative 135, so negative 135, if you have a circle, you're going in the negative direction, well, this would be negative 90, this would be negative 180. Is it negative 135 between negative 90 and negative 180? Yep. So in this case, we're going to be in quadrant 3. And the easiest thing to do here would be to make negative 135 degrees is coterminal with 225 degrees. So what we're going to do in quadrant 3, in order to figure out our reference angle, you take the 225 degrees minus your 180, because that's what it says in quadrant 3. We're trying to find our distance back to our horizontal. So this would give us 45 degrees. So our theta prime, our reference angle here, would be 45 degrees. Don't forget, reference angles are always less than 90, and they're going to help us solve some problems here in el future. That's Spanish for the future.